12.4 personal property loans. We're going to define personal property and real estate. Items that can be moved from one location to another, such as an automobile, a boat, or a stereo, are called personal property. In contrast, land and homes cannot be moved and are called real estate or real property. Nice little picture here. Real property is like a home, maybe some land that you've bought some out in a rental property somewhere by a lake. And personal property would include vehicles and boats. Okay, so use the formula for amortization to find the payment. The payment is going to be equal to the loan amount times the number from the amortization table. Another table we can use to solve for the payment. Sven Yarborough is a mechanic at a Ford dealership. He was so impressed with the quality of the Fords that he purchased an SUV at a cost of $29,400, including tax, title, and license. After the rebate, he made a down payment of $3,500 and financed the balance at a rate of 6% per year for 4 years. Find A, the monthly payment, B, the portion of the first payment that is interest, and C, the balance due after one payment, and D, the interest owed for the second month, and E, the balance after the second payment. So we'll go through this. Pretty straightforward. First of all, we need to figure out how much was financed. The amount financed is going to be the difference between the cost of $29,400 minus the down payment. The down payment was $3,500. So what he financed was $25,900. All right, so use the rate is 6%, but there are monthly payments. So there are monthly payments. We're going to take the 6%, divide that by 12. And so the monthly rate, the 0.5% per month, and 4 years. 4 years is the number of years that, yeah, it says 4 years. That's what's going to be financed. Times it by 12 to come up with the number of months. So I, or the rate is 0.5. I equals 0.5% monthly rate. And then the number of months is 48. So N equals 48 and I equals 0.5%. So we'll find on the table using 0.5 and 48 months, 0.5% and 48 months. 484. 0.5% is 0.5%, and 48 months, we're going to scroll all the way down to 48, 0.02349, 0.02349. 48 months, 0.5%. Okay, 0.02349, just like we left up on the table. So the monthly payment is going to be the amount borrowed of $25,900. We figured that out here, multiplied by the rate that we just came up with, 0.02349, and that equals $608.39. So Sven is going to pay monthly payments of $608.39. And then from here, we're just going to do like the amortization schedule that we had learned to do in a previous example, figuring out each month how much is paid and how much goes towards the interest and how much goes towards the principal. So the first, in the interest for the first full month, it's going to be I equals PRT. We're going to take $25,900, that's the outstanding balance, multiplied by 0.06, which is the 6% times 1/12, that's PRT, P, R, and T. If you can do that computation, it'll come up with $129.50. That's the interest. Now, Sven made a payment of $608.39, but of that payment, $129.50 went towards interest. 608.39 minus the $129.50, poof, that money's gone, that went towards interest. The balance now gets applied towards the principal. The principal started off to be $25,900. We're going to subtract the $478.89, and what do we come up with? We come up with $478.89. That's the principal portion. The balance was $25,900 minus the $478.89. That's going to give us a balance after that first payment of $25,421.11. First payment is done. We're off and running. We go to the next payment. We then, again, recompute I equals PRT, but not based upon the original balance. Now we're going to do it based upon the reduced balance of $25,421, what we just figured out. We're going to multiply that times the same 6% times the same 1/12, that's 1 month. And now the interest is actually dropped for the second month. It's 127.11. That does make sense because it's dropped because the balance is lower now. There's less money that's being borrowed. The payment has been made. Now the interest is going down. So 127.11 is the interest. We're going to take the total payment of $608.39. We figured that out in A or B. And then we're going to subtract the 127.11. And now the amount that goes towards the principal is a little bit higher than the one on the first payment. The amount is $481.28. Now we'll take our balance that we computed in C, and we're going to subtract the $481.28. That portion goes towards that principal, and now the principal has reduced after the second payment to $24,939.83. Okay, here's kind of a payment amortization schedule that's actually being drawn up on a real-time basis, 1 and 2, and you can see how it's going to work. And you can do this for every payment all the way up to payment 48, so that if everything works perfectly on payment 48, the loan balance after the payment will be 0. Example number 2, Ruth Ginseng needed $22,300 for equipment for her car wash. Due to issues with her credit history, the bank required her to put $5,000 down and agreed to lend the balance at a relatively high 12% rate, compounded quarterly with quarterly payments spread out over 2 years. Find the quarterly payment and show the payments on a table called an amortization schedule. Now we'll work through this. We've actually done all this already before to a limited degree, but we take the amount financed is $22,300 minus the, now this time she put $5,000 down. So the balance, what's going to be financed is $17,300. The factor we're going to use on the table to come up with the payment amount is 12% divided by 4, which is 3%. And then the number of payments is going to be 2 payments or 2 years. Is that what? Spread out over 2 years. Yeah, 2 years times 4 payments per year. That's quarterly payments. So the number of payments is, or number of payments or payment periods is 8. 8 and 3%. So let's go look. 8, 3%. %3 is here, and number of payments, scroll down to 8. I guess we should do this. 8, we'll go to 8, and then come across until we get to 3%. 0.14246. 0.14246. Okay, we'll carry that factor over so that we can compute the payments. 14246 multiplied by the amount that's being borrowed, which is $17,300, gives us quarterly payments of $2464.56. Okay, so to compute the, let's go, we have an amortization schedule. We're going to, the first year is 0, the balance is $17,300. We're just going to compute the very first payment, and then from there we can just run with it, or you can run with it. How's that? We know that for the first payment, we still owe $17,300, so we're going to compute the interest based upon that $17,300. So we'll take the balance of $17,300, we'll multiply it by the quarterly rate of 3%. The quarterly rate of 3% is what we came up here, okay? We'll take $17,300, we'll multiply by 3%, and that's going to give us $519. That gets plugged in as the interest for that period. So our total payment is $2464.56. The interest is 3% times the $17,300, and that gives us $519. And now the principal portion, or the portion to the principal, will be the difference. $2464.56 minus what goes to interest. Poof, that money's gone. The remaining balance goes towards the principal. So now we're going to take the $17,300, we're going to subtract the $1948.56, and that gives us $15,354.44. So that's our balance after the first payment. In the second payment, $2464.56, you can see every one of these payments is the same. The interest now is recomputed because we're going to take the balance after the first payment of $15,354.44. We're going to multiply it by 3%, and that's going to give us $460.63. the total payment, $2464.56, minus the $460.63 that poof is gone, it goes towards interest, leaves us a balance of $2,393. This goes towards the principal. So we'll take our principal portion or principal balance, we'll subtract the payment towards the principal, and that gives us $13,350.51. And we just repeat that eight times. We're not going to do that right now because that's just, we're just doing the same thing over and over. But when you get to the very end, the balance should be zero. There might be a slight modification in the last payment simply because the interest, it's not perfect. There'll be some small rounding amounts. So that last payment may be a little bit different. There's the amortization table. Now there's a loan payoff table as well here. So let's see what this is about. The loan payoff table that follows can be used as an alternative to the amortization table on the prior page. It shows higher interest rates and longer terms. Personal property loans often involve higher interest rates since people are more likely to default on a loan for, say, a digital television set than a loan for their home. Furthermore, individuals with poor or no credit history must often pay higher interest rates. This table has a different format from the table on the preceding page. The APR is down the left column and the number of months is across the top. So find the loan payment. Payment equals the loan amount times the number from the loan payoff table. Okay, so this probably will be pretty straightforward. After a trade-in, Vicki Ewing owes $17,400 on a new Harley-Davidson motorcycle and wishes to pay the loan off in 60 months. Her banker told her that the interest rate would be somewhere between 9% and 14% depending on her credit history. Find the monthly payment at both interest rates. Okay, let's see if we can do that. Find the monthly payment at both interest rates. So we have the factor here. We have $17,400. I think we need 60 months, and we need the interest rate somewhere between 9 and 4%. So first 9%. So we use 9%, and we're going to scroll all the way to 60 months, which gives us 0.02076, that's the first factor we're going to use for 9%. And then the 14% will be 0.02327, 0.02076 and 0.02327. So monthly payment at 9% is the balance, 17.4 times for the 9% is at 0.02076. That gives us a monthly payment of $361.22. The monthly payment at 14% computes out to be $404.90. Find the total finance charge at both rates. Well, to do that, we simply need to figure out, well, how many payments is she going to be making and at what amount? So under the 9%, she's paying 60 months and she's paying a total $361.22. That's the total amount of payments, the total payments that are going to be made. Well, this includes both principal and interest. So we're going to subtract the original principal, and that means that over the life of the loan, she's going to be paying $4,273.20. Under the 14% option, she's going to be making payments of $404.90. That multiplied by the 60 gives a total amount she's going to be paying. We're going to subtract from that the principal, and that has to be left with the finance charge or the interest that she's paying. By the way, finance charge, interest, those are used interchangeably, okay? So now the extra costs on poor credit, well, she's going to pay for 14%, she's going to come up with paying $68.94, but for 9% better credit, she'll end up just paying $42.73.20. Let's take the difference. In other words, because if you have poor credit and you have to pay 14 rather than 9% with good credit, then that would cost an individual $2,620.80 more because they do not have good credit. That should be a motivator for you to try to keep your credit on there. Was that her? Let's go back. Yeah, there she is. She's driving off with her Harley. She's probably happy. If she's happy, she probably got the 14%. Okay, that's the end of 12.4.